Now, go for it, Dorian. What's happening in this one?
A mass
Yeah.
of 0.15 kilograms is hung from the end of a spiral spring.
Okay.
The mass is given a small vertical displacement of 15 millimeters and released so that it vibrates with simple harmonic motion.
Okay.
Determine the spring constant if 25 vibrations take 11.6 seconds.
25 oscillations take how long?
11.6 seconds.
So then that means T is 11.6 over 25, right? Which is equal to 2 pi root m over k. So k would equal 2 pi times 25 over 11.6 times root 0.15 all squared. Yeah. What do we get? So, can you type that in, please? 27.5. So, is that the end of the question, or is there more? Dorian, is that the end or more?
No more, that's the one I was trying to determine the maximum speed of the mass.
Ah, well, that's using our buddy. A couple of choices. We could use. Well, no, the simple harmonic one. V squared equals omega squared a squared minus x squared. Or you can put it with the square roots too. Or V equals omega root a squared minus x squared, right? Same thing. So then that means V max equals omega a, which equals 2 pi a over t, which is 2 pi 0.015 over 11.6 over 25. What's that, Gina? $2.03. Thank you. Yeah.
Question for K.
Yeah.
So why does it convert it as a square out of brackets?
Because the k is inside the square root. So really I got root k equals this. So then I had to square it, you see. Oh, sorry, thank you. Yeah, sorry. Meters per second. Was that the one you had a problem with? Was that the part you had the problem with?
Yeah, I just wasn't really sure.
Okay. Yes?
So can I it to like both two square?
You can square both sides from the beginning. Yeah. Is that what you would do? That's fine, yeah. Yeah. Any other questions?
Number 5.
Yeah? What's number 5 about?
A spiral spring is extended 8 millimeters by a force of 1.5 newtons.
Hold on. So it's extended
Part B,
8 millimeters by a force of
1.5 newtons.
okay.
Determine the force constant of the spring.
Okay, so that's okay. That's F equals kx. So k equals F over x. So that's 1.5 over 0.008. Okay, whatever that is. What is that, by the way? 187.5. Okay, what's the next part?
The spring is then fastened at one end of a smooth horizontal surface.
Mm-hmm.
and a mass of 0.6 kilograms is attached to the free end. The mass exploded 4 millimeters and released 1. Determine the period of vibration of the mass.
Okay, so that's T equals 2 pi root m over k. What's that? Thank you, Gina. What is it? Thank you, thank you. Okay, and next?
Determine the maximum velocity of the mass.
That's A omega. Zero 0.004 times 2 pi over t. My good friend Gina will tell me what this is. What is it, Gina?
0.0708.
Okay. Is there more to it?
What does resonant frequency vibrate? Is that T?
Just frequency. Did it say resonant frequency in this question?
No.
Okay.
Just says determine the resonant frequency of vibration.
Yeah, that's what I asked. Did it say resonant in this question?
No, not in this one. In another.
Oh, right. Well, the resonant frequency only really makes sense when you have two things vibrating. Like the context of resonance is one thing's vibration causes another thing to vibrate. What's the context here, Zach?
It's the same. A mass suspended from a spiral spring. Spring is extended. Determine K. Then it says determine the resonant frequency.
Oh, I don't know. I feel like that word is very redundant.
So what are they asking for?
The frequency. Yeah. They said determine the resonant frequency, did they?
Yeah.
Yeah, so that's the F. Yeah. I don't know, Zach, I would use a different word, a different adjective. I would use something like harmonic frequency, you know, oscillating frequency, simple harmonic motion frequency, or just frequency. Right, do we need to see anything else? Okay, well that's good. Did you have any trouble? Did I do 3? Yeah, okay. Okay. Oh, Diego, how many questions did you do last night?
5.
Honest?
Yeah, that's.
You weren't up watching Rick and Morty?
Well, 4 and something.
Because I was. Watching Rick and Morty?
Are they releasing episodes every day?
What's it?
Every week. It's episode 2 now, season 4.
What's that?
It's apparently scheduled for part 2.
I know, I found out last week.
Really interesting.
It's great. So they have, episode 2 was last night, episode 1 was last week.
Oh, wow.
Saw a little bit of the a preview of it.
Of which one?
Rick and Morty.
Yeah, which episode?
I don't know, it's a preview of them in some weird dimension, then this monster comes
But that's
out.
like every episode. That's,
Okay.
you need to be much more specific than that.
I don't know.
Like, oh, in a different dimension with aliens? No, that's like
Yeah.
90% of the episodes.
Something about Rick telling Morty to trust him or something.
Yeah. Yeah, you need to be more specific than that.
You gotta trust me, Morty.
I just find, I just,
for the research, Morty. You gotta stick with
yeah,
me straight up.
you need to do me a solid.
Yeah.
Oh, classic. Morty's voice is just so funny. It's just,
Yeah.
it's just so funny.
Voiced by the same guy.
Is it?
Yeah.
I did not know that. That's interesting.
And he always records Morty first because if he does Rick first, his voice is just messed up. And
Oh, yeah, okay.
Oh, wow,
Okay,
yeah.
I got you. Yeah. Now, will we start the next lesson or is there anything else in homework? How many did you do, Gina, last night?
Which topic?
The Hooke's Law.
Oh,
Is that 10 of them, is it?
no, just 7.
Okay. And did anybody get to try Young's modulus?
No.
No. Really? Yeah. What about the results?
Yeah.
I gave them to you.
No, I mean the people.
Oh, you don't get that back. I need to keep that.
Ah.
But you're welcome to see me in the office to discuss anything with it. That's no problem. Just send me an email. No, I just want to check how many Young's modulus questions have been done for you? And zero.
What?
Young's modulus questions. How many have you done at this point? Zero. Okay. Gina? Zero. Zero. Harry? Oh. Zach?
No.
Okay. Before I go to the next lesson, I want everyone to do one question now and then do some more tonight. Okay?
I'm going to do question 24.
No, let me see. What's question one like? I'll tell you which one to do. No, don't listen.
Question 24 looks interesting. So.
What's question 24?
Don't annoy me. Hang on, wait guys, I'm going to find a good one for you. Ooh, I think I might have found it. $24. Do that one. Do that one now. And then I'll do it in a minute, okay? Finished, Gina? No? Anybody finished yet? Okie dokie, guys. Have we got that finished, or is it a little too hard? How's it going, Harry? Yeah?
You have the pottery.
Pottery's a problem? And let me open up the question on my smartphone. We'll start it now.
This horrible scale is messing with my brain.
Oh, be strong. Generate worksheet. Right. What number did I say?
194.
Which one, sorry? 24, was it?
ID 194.
Yeah.
Question 24.
Okay. Whoa. Okay, let's have a look at this. Okay, you ready, guys? Let's have a look. A copper wire of length 1.6 and diameter 0.8 millimeters is suspended from 2 points 1.4 meters apart and at the same horizontal level. A load of 3 kilograms is hung from the center of the wire. Determine the stress in the wire. So it's like this, isn't it? And then you have your weight here hanging on it of 3. Yeah? What's wrong, Dorian?
I didn't understand the question.
Ah. And then these are
0.7.
0.7. Yeah. Now, one thing that annoys me about this question. Okay, so hang on, let's get started. First, we want the stress, which is the force over the area. Now, I've no problem with the force.
What's the area?
Yeah, I'm not clear what the area is supposed to be here. Is it one string? Is it two strings?
It's one string that's attached at 2 points.
Yeah, I suppose in my head, my question is, do I take the area as being one or two circles?
You see,
Just one, because it's like one.
because the tension is not in the direction of the force. So would you resolve first and find that force?
You're right, Zach.
and
Actually,
find the
you're
force
right.
per each area.
We should resolve it, shouldn't we?
Yeah.
Oh, so now I understand why they wanted to give these distance too,
Yeah.
so we could resolve it. So actually, the force isn't even necessarily the tree. The force would, if we just look at one piece, the force is going to be the tension over the area. If we just examine one part of the string.
Stress on one side.
Mm.
Yeah.
Although, do we then need to double our answer?
That's what I thought as well.
Okay, one problem at a time. Let's resolve this. So that T has a component left and right, doesn't it? I don't really care about the left one. I actually care just about the top one, which is T sine theta.
Which is negative.
Yeah. Now, here's theta, right? So here's theta, right? Sine theta would be opposite over hypotenuse. Has anybody got this length out from Pythagoras?
Yeah, that's
Yeah.
what, it's hard to picture because
It's
it's
1.063.
No,
Same,
no,
mate.
no.
0.38.
0.3,
Fine is that,
0. Point,
Sorry, 0.38, yeah, sorry.
0.38. Okay, so what is 0.38 over 0.8?
0.39. 387.
It's
Right, so the total force up will be 2T, which will be 2 times, what did you say? 0.38 over 0.8?
Root
0.387.
15 over 8 or 0.484.
T. And then if you multiply that by 2, because there's 2 of these.
Yeah.
Come on, what's wrong? What's wrong? What's wrong?
Are we using lambda here to get no, but you don't have
You don't have any
any
angles.
angles.
Yeah.
You get to
You could get the angles, yeah, you could. You could, yeah, you could. You could. What is this?
0.968.
T. Okay, and that should equal trig G. Shouldn't it? The two vertical tensions should equal trig G. Shouldn't it? Zach,
Lost.
what's with the
It's
face?
same as
It is the same as Lamy. Thank you.
because I used Lamy.
Oh, good.
Yeah, it's same answer as well.
Okay, well, this makes me happy. So, what's the T then? 30.4 newtons. 30.4 over pi. What's the radius?
Oh, it's not. It says 0.8 millimeter. Wait, divided by
0.8 millimeters is the diameter. So, yeah, thank you. So that's 0.004 squared. Right. So what's that?
It's,
Oh, I thought you had it. Oh, sorry. 0.4 of a millimetre, so it's not even 1 millimetre, sorry. So what do we get? Big number, right? What you get? 16 million?
6.048 times 10 to the power of 7.
Is that per wire now?
Now hang on, let me think. Let me think. Do we need to multiply this by 2? Let's read the question carefully. Determine the stress in the wire. I'm going to cross my fingers and say no. And then if somebody would kindly open up the marking scheme and maybe break my heart.
Because the wire is being stressed downwards.
Just give me a second here to hope for the best.
Dorian, are you checking the marks?
Trying to.
Yeah, it's Physics 13-14, Semester 2, Version 4, A7.
No, this is the answer for the first one.
I'm right?
Yeah.
Oh, thank goodness. Okay, yeah. Now,
Why wouldn't you?
what would anybody like to say? What word in the question your teacher saw that made him think not to multiply by 2? There's not many words.
Center on the one.
It says the stress in one.
Correct, Dorian. In. In is the reason I didn't multiply by 2.
Or if it says on.
Maybe if it said on or total or something like this. But in sounds internal, so that just means you want just one piece internally. So only because of the word in the question I didn't multiply by 2. But that's hard. That's hard. Right, let's see the next part. Okay, so once we got over this, I hope the next part, the strain, is that easy?
Yeah.
Because we have Young's modulus, don't we?
Yeah.
Yeah, so just
So Young's modulus is stress over strain. So the strain will be 6.048 times 10 to the 7 over 1.17 times 10 to the 11. And what is that?
5.17 times 10 to the minus 4.
No unit. And finally, what's the extension? That's using the previous result. So it's going to be 5.17 times 10 to the minus 4 times... Ooh. Ooh.
You see, this one I also didn't get because
0.8 or 1.6? Let me think. Okay, I'm going with 0.8. Can you tell me what I
see
get?
the marks.
Wait till I get an answer. We'll see. We'll see if I'm on a roll. What do we get if we multiply here?
0.8, 4.14 times 10 to the minus 4.
Yeah? So, if I was to multiply that by 10, so that's 0.414 millimeters. Dorian, would you, since you have the question open, the answer open still?
Yeah. The answer for
The last part. Last answer.
0.827.
No!
So it's 1.6.
Wait, that's weird. 5.17 times 10 to the
Oh, wait,
power
what?
-4 times 1.6.
Yeah, I put in 0.8. I
Ah,
wasn't sure if I should put in 0.8 or 1.6.
1.6.
Why? Why 1.6? I'm not happy with that. Why 1.6? Yeah, but the wire's looped. It's being pulled from the middle, not from the end.
No, but then there would be
Maybe they
two
consider
sides.
that
Extensions
the
here.
whole cable then.
So
Oh!
it's probably
Isn't it?
extensions.
No, no.
0.8 times
No.
2.
Gina's given me the idea. Sorry, thank you. So what I've in my head, I was picturing this. It extends here. I was just looking at the left. So, but you're right, Gina. Sorry, it's even though it only moves down a little bit. I think they want the total extensions. The other half extends as well, so I should multiply my answer by 2.
It's 0.8
Yeah, so
times
it's
2.
0.828 millimeters. Yeah, sorry. Again, yeah, in the wire. So the total extension, which includes the left and the right.
You know, because doesn't have a wire, is it?
Yeah.
No, it's 1. I believe 1 times 6.
Well, yeah, that's all.
Okay, so I know it might seem like it doesn't matter, but in my mind, it makes more sense to think about it like this. If you can look up, please. I prefer to think about it like this
Instead of 1.6.
instead of this. Which, of course, I know it's the same thing, but in my head it makes more sense to think about it like this because I'm thinking about it like that. Whereas when it's written like this, I'm thinking about it like this. I don't know, that's just the way I think. Any opinions on that? No? Are we happy that it's like this? Well, maybe we're not happy about it, but do we understand it? Yeah, well, if I was only going to make you do one question today, I thought it should be a tough one, right? Okay, we'll start the next chapter. So, can you try to do some of those tonight, please?
Through chapters.
Hmm?